All right, so our final two examples, we're going to put together everything that we've discussed in terms of amplitude, period, phase shift, and vertical shifts. So here we have a sine function. Okay, so y equals 2 times the sine of x minus pi over 4 plus 1. And so you want to recognize that anything that is happening on the outside of the sine function is going to happen to the output values in terms of their order of operations. And anything happening inside the parentheses here is going to be done to the input or your x or your theta. So let's look at creating a chart. So remember, when you see something inside the parentheses here, when you set that equal to 0 and solve, that's going to give you the operation that we need to do to the x or the input. So all of my inputs, I'm really going to add pi over 4 to all of my inputs. And then to my output values, I'm going to have to multiply 2 times the sine of my output plus 1. And so this just shows me what I'm going to be doing in terms of my operations to my inputs and outputs. So we always start with our 5 standard inputs. Right. And to each of these I want to add pi over 4. I'm just going to write that down. Now with these you are going to need to be able to add fractions, and with that means you need to get common denominators and know how to add and subtract fractions pretty quickly. And so the first one is fairly easy. All right, so now you have to think, if I multiply top and bottom of the first fraction by 2 to get a common denominator, then in the numerator I'm going to have 2 plus 1, which is going to be a 3 of the pi over 4. Same thing here. Top and bottom by 4 means in the numerator I have a 5 pi over 4. All right, that's going to give me a 6 of the pi over 4 plus 1, which is 7. And again, multiplying top and bottom by 4 gives me 8 plus 1, which is 9. All right. So if at any point these fractions can be simplified further, you're going to want to go ahead and do that. If not, just leave them alone the way they are. All right. Likewise, I'm going to have to think about my output values and multiply times 2 and then add 1. All right. And so when I look at my sine function, all right, again, this 0, 1, 0, negative 1, 0 is my standard outputs, and then the operations happening to it. So my outputs, I'm going to have a 1, 3, 1, looks like negative 1 and 1. All right, so let's answer our questions. Our amplitude is 2. In this case, our period is still 2 pi because there is no number other than 1 sitting here in front of the x. My domain is now going to go from pi over 4 to 9 pi over 4. I can see that my range is going to go from negative 1 to positive 3. My midline is y equals 1. And then I also need to state my phase shift. And my phase shift was what happened when I took that x plus pi over 4 and set it equal to 0 to solve, which means I'm going to be moving to the right by pi over 4. And I can also see that because my first coordinate starts at pi over 4. So let's make our graph. Let's try to make a graph that will encompass all of these values. All right. So now again, I need to make sure that I can at least go down to where y is a negative 3. So there's negative 2 and negative 3. And I want to make my increments nice and neatly spaced. And so the first one here is going to be my pi over 4. I'm going to label them exactly what I have here. So that's a 1 pi over 4. All right. Now, I have to be careful because if you think about how these are actually in terms of numerators, that's a 1 of the pi over 4, which means this is 2 pi over 4, 3 pi over 4, 4, 5, 6. I'm going to actually have to extend this out a little bit further. Right. So 7, 8, which makes this 9 pi over 4 right here. So when you make your graph, especially one that you have to make on your own, you need to make sure that the increments are evenly spaced, and you don't just label the ones you have sometimes with the exact numbers. All right, so they're all the denominator 4, so in terms of the numerator, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I can start my coordinates. All right. So, oops, I went down to 3, not up 3. Oops. I put my y-axis in the wrong spot. All right, so let's see. There's my midline. So I'm going to start here. And then at 3 pi over 4, I'm actually going to go up to 3. 5 pi over 4 is back down. All right, 7 pi over 4 is at -1. And then back up again. Right, so here's my sine function. All right, so my graph, you can see, is shifted over. It has an amplitude of 2 and is moved outward. Right. So let's look at one more. This is an oddball one. Something that you are going to need to know how to do is when you have also a period adjustment inside here. And in general, you're going to want to remember your order of operations again. So again, anything happening on the outside is happening to the output. Anything happening on the inside is happening to the input. And the order that we're going to do this is going to be based off of how we solve for x. So in your inputs, you're going to have to think about the first thing that we're going to need to do is we're going to need to add pi to all of those. And then to solve for x, we would be multiplying by the reciprocal. And so we need to do it in that order as well. And I'm going to put my parentheses around this so that way I can make sure that I add the pi first. And then whatever that value is, I can take a half. And then to my cosine values, I'm going to need to multiply a -1 times all of my cosine values and then add 3. And so it doesn't matter which side we work on first. I'm probably going to work on the right-hand side first because I think that's going to be easier. All right. So I'm just going to write in all of my operations that I'm going to do to cosine. And think about my output values. All right, so -1 plus 3 is a 2. And then 3. This is going to end up bringing me up to 4. 3. And then back down to 2. And so now I want to give myself a lot more space over here to do my operations. Because again, I'm going to have to take 1/2 of my input value after I add pi. Right. And so I'm going to write down everything that I need to do and give myself a lot of space to do it. Right. Now sometimes you may want to do this on a separate sheet of paper. Sometimes you're just going to want to use your calculator. Right. So 0 plus pi is pi. 1/2 of that is pi over 2. Right. Now when I get a common denominator right here, then that's going to give me a 1/2 times a 3 pi over 2. Right. And so when you simplify down what's happening here first, then you can multiply by the 1/2. This is really 3 pi over 4. Right. Or I need the next one is 1/2 of 2 pi, which is at pi. Right. Same thing here. All right, top and bottom of by 2 means that in the numerator I'm going to have a 5 of the pi over 2's, which is going to give me a 5 of the pi over 4. Right. And then here I need 1/2 of 3 pi, which is 3 pi over 2. And what happens is when you have these unlike denominators, sometimes it's easier to figure out how this is going to be graphed by making sure these all have the same denominator. And so this pi over 2, this would be the same thing as if I multiplied top and bottom by 2, or have 2 pi over 4. And then this is the same thing as 4 pi over 4. And this is 6 pi over 4. So when I make my graph, I'm going to be using the increments of 2, 3, 4, 5, and 6 with my pi over 4 increments. So let's look at all of our other special values first. My amplitude is a positive 1. Right. Now, my period is going to be the 2 pi divided by my b value, which is 2. And so my period is just pi. My domain, I'm going to look at my chart, and that started at pi over 2 and ended at 3 pi over 2. My range is going from 2 to 4. My midline is y equals 3. And for my phase shift, right, if I'm not sure, again, I want to go and set everything that was inside those parentheses equal to 0 and solve. And so what is going to happen with my phase shift, it's going to end up being a right by pi over 2 when I solve. Right. So let's graph those. Right. Now when I make my graph, again, I have to remember that it goes up to 4. Right. So I don't want to lose that. Right. And I have my midline right here. All right, so these are going to be increments of pi over 4. So this is 1 pi over 4, 2 pi over 4, right? 3, 4, 5, and 6 pi over 4. All right? And so if this is, you can write that down as 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, and then 6 pi over 4. And so every time I have something that is a pi over 4 that could be simplified, I did that with my pi over 2s, which is also on my chart. So again, let's plot these points. Right? At pi over 2, I'm here at 2. Right? At 3 pi over 4, I hit 3. At pi, I hit 4. At 5 pi over 4, I'm back down. And at 3 pi over 2, I'm back down again. Remember that I know that looks like a V shape, but it's not. You want to try to connect it as best you can. Right?